Derivative of exponential and logarithmic functions. Let us remember these three basic rules. Derivative of e to the x is e to the x. E is a known constant. Then derivative of a to the x is a to the x natural log of a. This a is any constant. Now derivative of natural log of x will be 1 over x. We'll take a few more examples similar to these formulas. Look at example 1, 13 to the x. So 13 is a constant, so that goes with this. Then your derivative will be 13 to the x natural log 13. Take example number 2, derivative e to the 7x. It's very similar to this one, but you need to do chain rule also. So e to the x derivative is e to the x, which is 7x. Take the derivative of 7x and multiply with it. You are done. We'll take example 3. Let me take a function, natural log of 3x. You want to take derivative. So natural log of x we know is 1 over x. So we can say 1 over 3x. And then derivative of 3x is 3. So then you get 1 over x. Let us take a more complicated situation. I'm still getting logarithmic function, but my base is 3. It's not natural log. So then you need to change the base first. This one can be written as natural log of 2x plus 7 divided by natural log of 3. That you have learned in pre-calculus, how to change base. Now natural log of 3 is a constant in the denominator as a coefficient. Leave it there. The natural log of this will be 1 over 2x plus 7, and then you need to take derivative of inside, which is 2. And you are done. We take two more examples. Watch carefully. One is natural log. This is the argument, has exponent 3, but this one is everything has exponent 3. So when you do the first one, say y prime or dy dx. So before you do that one, you can just do one algebraic part. This 3 you can bring in front with the property of logarithm. And then when you take the derivative, leave your 3. Natural log of this will be 1 over 2x plus 7 and times inside derivative is 2 with the chain rule. So you get basically 6 over 2x plus 7. Now when you do this one, this is little different. Now you can say everything is your x to the 3 will give you derivative 3 natural log 2x plus 7 is squared, then the derivative of inside, which is 1 over 2x plus 7, and then inside gives you 2. So you can see the difference between these two. We are taking two more examples. First one is natural log with this argument. If you do some algebraic part of it, it will be x squared minus 7 to the 1/3. So then using the property of logarithm, exponent you can bring as a multiple. So we get x squared minus 7. Now take the derivative. So you just say y prime, you keep your 1/3. Derivative of this one will be 1 over, and then take the derivative inside, which is 2x multiply. You are done. This one is a product rule. I usually prefer like this. 10 to the x is one function. Natural log 5x is another function. So take the derivative of this one. It will be similar to a to the x. So you get 10 to the x natural log of 10, and this one will give you just 1 over x. You know this. Cross multiply, add together. So you get y prime equals 10 to the x. I'm doing this way first, but if you do other way, nothing wrong. Plus other side. 10 to the x over x. You are done. Two more examples. This one is natural log cube root of x minus 3 over x squared plus 7. Now let's apply some property of logarithm that will make it easy. Natural log, you have x minus 3 over x squared plus 7 to the 1/3. 1/3 you can bring in front, and then natural log this over this, you can use a property, this minus natural log of x squared plus 7. Now when you take the derivative, f prime x is so simple. 1/3, this derivative is 1 over x minus 3, and then inside derivative is 1, so you're done, minus this one will be 1 over x squared plus 7, and then derivative of this one is 2x, you can write here. You are done for number 9. I want to do number 10, but let me have some space here. So we can rewrite our problem with the logarithmic properties, that you will write natural log x plus 3 squared plus natural log x minus 2 to the 3, and then apply again property, 2 will come in front, 2 natural log x plus 3 plus 3 natural log x minus 2. Now when you take the derivative, that gives you 2, and then this one will be 1 over x plus 3 plus 3 1 over x minus 2.